Good morning everyone. My name is Ishan Sachar and today I will be presenting on the topic History and Architecture of the Unix Linux kernel. This topic is important because Unix and Linux have played a major role in the development of modern operating systems. Most of the servers, cloud platforms, supercomputers and even Android smartphones today rely on Linux based system. In this presentation, I will explain how Unix originated, how Linux evolved from Unix concepts, what a kernel is, how the Linux kernel is structured, and why it is considered one of the most successful software projects in history. Before discussing Linux, we need to understand the importance of Unix and the concept of a kernel. Unix was developed at AT&T Bell Labs in 1969 and became one of the earliest operating systems to support multiple users and multiple tasks at the same time. At a time when computers were expensive and limited, Unix introduced a more organized and efficient way of managing computing resources. The second concept shown on this slide is the kernel. The kernel is often called the heart of the operating system. It is the software layer that sits between the applications of the hardware. When we open a file, launch an application, connect to the internet, or save data, the kernel manages those operations. It controls the CPU, memory, storage devices, and other hardware components. Without a kernel, applications would have to communicate directly with hardware, which would be inefficient and unsafe. Therefore, the kernel acts as a manager that ensures all resources are allocated properly and securely. This idea of having a powerful and efficient kernel is one of the reasons Unix and Linux become so successful. Now, let's look at the history of Unix. Unix was created in 1969 at Bell Laboratories by Ken Thompson and Dennis Ritchie. Their objective was to design an operating system that was simple, efficient, and portable. One of the biggest achievements of Unix occurred in 1973 when it was rewritten using the C programming language. Before this, most operating systems were written in assembly language and were tied to specific hardware. By rewriting Unix in C, it became much easier to move the operating system from one machine to another. This portability made Unix extremely popular in universities, research laboratories, and businesses. Unix also introduced many concepts that are still used today, such as hierarchical file systems, multitasking, multi-user support, and command line interfaces. As Unix spread across the world, different versions were developed, including BSD Unix, Solaris, AIX, and HPUX. Because of its strong design and principles, Unix became the foundation for many future operating systems, including Linux, Mac OS, and several enterprise server platforms. Moving on to Linux, in 1991, a Finnish computer science student named Linus Torvalds started developing a new operating system, kernel, as a personal project. Linus admired the design principles of Unix but wanted a system that was freely available to everyone. He therefore created Linux and released its source code to the public. This decision made was revolutionary because developers from around the world could now contribute improvements, fix bugs, and add new features. Unlike proprietary software, Linux followed the open source model. This allowed rapid innovation and continuous development. Over time, Linux became more powerful and stable. It became to replace expensive Unix systems in many organizations because it offered similar capabilities without licensing costs. Today, Linux powers web servers, cloud computing platforms, Android smartphones, embedded systems, smart devices, and all of the world's top supercomputers. The success of Linux demonstrates the power of open source collaboration and community driven development. Now, let's understand what exactly a kernel is. A kernel is the central component of an operating system. It acts as an intermediary between software applications and hardware resources. When an application requests a service, such as opening a file or accessing memory, the request is sent to the kernel. The kernel then communicates with the hardware and returns the required information. The kernel performs several important functions. First, it manages the CPU by deciding which processes should run and for how long. This is called process scheduling. Second, it manages memory by allocating RAM to applications and ensuring that programs do not interfere with each other's memory spaces. Third, it manages file systems by organizing data on storage devices and providing access to files and directories. Fourth, it manages hardware devices such as keyboards, printers, network adapters, and storage drives through device drivers. Because the kernel controls all critical system operations, it is considered the most important part of the operating system. Now, let's examine the architecture of the Linux kernel. The Linux kernel follows what is known as a monolithic architecture. This means that most operating system services run with the kernel space rather than being separated into different processes. The architecture shown here consists of three major sections. The first section is the system calls interface. System calls act as a bridge between user applications and the kernel. Whenever an application needs to access hardware resources, it uses a system call. The second section is resource management. This includes process management, memory management, and file system management. The kernel ensures that system resources are allocated efficiently and fairly among running applications. The third section is input, output, and networking. This part handles communication with hardware devices and network connections. Whether we are using a keyboard, connecting to Wi-Fi, or accessing a website, these operations are managed through this layer. One reason Linux is highly efficient is that these components work together closely within the kernel, reducing overhead and improving performance. This architecture makes Linux fast, stable, and suitable for both small devices and large enterprise systems. Let's now discuss the major subsystems of the Linux kernel. The first subsystem is the process scheduler. Every time multiple programs run simultaneously, the scheduler decides which process receives CPU time. It ensures fair distribution of processing power and enables multitasking. The second subsystem is the memory manager. Modern computers run many applications at once, and each application requires memory. The memory manager allocates RAM, manages virtual memory, and prevents programs from accessing memory that belongs to other programs. The third subsystem is the virtual file system, often called VFS. Linux supports different file systems such as ext4, XFS, and VTRFS. The VFS provides a common interface so applications can access files without worrying about the underlying file system type. The fourth subsystem is the network stack. This subsystem manages communication over networks. It implements networking protocols such as TCP, IP, which enable internet communication. Together, these subsystems ensure that Linux remains efficient, secure, and capable of handling complex workloads. Now, let us discuss some of the most important features of the Linux kernel. These features are one of the main reasons why Linux has become one of the most popular operating systems in the world. The first feature is that Linux is open source. This means that its source code is freely available to everyone. Developers from any country can study the code, improve it, fix bugs, and even create their own versions of Linux. Unlike proprietary operating systems where only the company can modify the software, Linux encourages collaboration. This has resulted in thousands of developers continuously improving the kernel over the years. The second feature is its modular design. Linux uses loadable kernel modules, which means additional functionality can be added or removed without restarting the operating system. For example, if we connect a new USB device, the required driver can be loaded automatically. This makes the Linux flexible and easy to maintain. Another important feature is multitasking. Linux allows multiple applications to run at the same time. For example, while listening to music, downloading files, browsing the internet, and editing a document. Linux efficiently shares the CPU among all these processes. Linux also supports multiple users. Different users can log in into the same system with separate accounts and permission. Each user has their own file settings and access rights. This feature is especially useful in universities, companies, and servers where many users share the same machine. Of Linux. Every file has permissions that determine who can read, write, or execute it. Linux also provides user authentication, process isolation, firewalls, and regular security updates. These features makes Linux much more resistant to viruses and malware compared to many other operating systems. Finally, Linux is known for its stability and performance. Many Linux use servers run continuously for months or even years without needing a restart. This high reliability is why Linux is trusted by most organizations around the world. This slide shows the impact and advantages of Linux on a global scale. One of the biggest advantages of Linux is its scalability. Linux can operate on a very small embedded device with only a few megabytes of memory, and it can also run on extremely powerful supercomputers containing thousands of processors. Very few operating systems are capable of working efficiently across such a wide range of hardware. Linux is also highly cost effective because it is open source. Organizations do not need to purchase expensive software licenses. This reduces operational costs significantly, especially for companies running thousands of servers. Another important advantage is high performance. Linux uses system resources efficiently, allowing applications to run smoothly even under heavy workloads. This makes it suitable for cloud computing, artificial intelligence, and scientific research and data analysis. Linux also offers excellent customization. Developers can modify the operating system according to their requirements. Different Linux distributions such as Ubuntu, Fedora, Debian, and Red Hat are all built on the same Linux kernel but provide different user experiences. One of the most interesting facts shown on this slide is that Linux powers 100% of the world's top 500 supercomputers. These machines perform weather forecasting, medical research, space exploration, artificial intelligence, and complex scientific calculations. Linux is also the backbone of the internet. Most websites that we access every day are hosted on Linux servers. Cloud platforms like AWS, Google Cloud, Microsoft Azure rely heavily on Linux because of its reliability and security. Even Android smartphones uses a modified version of Linux kernel. This means billions of people around the world use Linux every single day, often without realizing it. These examples clearly show why Linux has become one of the most influential operating systems ever developed. To conclude, Unix and Linux have had a tremendous impact on the world of computing. Unix introduced many groundbreaking concepts such as multitasking, multi-user support, and portability. These ideas influenced the design of countless operating systems. Linux built upon these principles and made them accessible through open source development. Thanks to contributions from developers worldwide, Linux has evolved into one of the most powerful and widely used operating systems. We also learned that the kernel is the core component of the operating system. It manages, processes, memory, file systems, networking, and hardware devices. The Linux kernel's architecture and subsystems work together to provide high performance, reliability, scalability, and security. Today, Linux powers servers, smartphones, cloud platforms, supercomputers, and many embedded systems. Its success demonstrates the importance of collaboration, innovation, and strong software design principles. Thank you for listening to my presentation. Thank you everyone for your time and attention. I hope this presentation helped you understand the history and architecture of Unix Linux kernel. I would be happy to answer any questions.